Function f, the falling edge pulse with auxiliary, is a negative edge triggered one-shot that makes use of both the auxiliary controlling input and the A1 to A2 coil input. A timing diagram of function f would look like this. Note that the one-shot is triggered for a period t on the negative going transition of the auxiliary controlling input. If the coil was depowered while this one-shot was in the process, it would override the ongoing one-shot. This is kind of equivalent to a reset. Additionally, note that this manufacturer states that the auxiliary controlling input must be present for at least 35 milliseconds for it to register the negative going transition. This particular function is non-retriggerable. Finally, function G, pulse forming with auxiliary voltage, is a positive edge triggered one-shot that makes use of both the auxiliary controlling input and the A1 to A2 coil input. The timing diagram of function G would look like this. Note the one-shot is triggered for a period t on the positive going transition of the auxiliary signal. If the coil was depowered while the one-shot was in the process, it would override the ongoing one-shot. This is kind of equivalent to a reset. Additionally, note this manufacturer states that the auxiliary controlling input must be present for at least 35 milliseconds for it to register the positive going transition. This particular one-shot function is also non-retriggerable. If you think about it, really the only difference between function G and the previously discussed function E, rising edge pulse, is that function G is looking for a positive going transition of the auxiliary controlling input signal rather than the coil. As long as the auxiliary controlling input lasts longer than a minimum of 35 milliseconds, receipt of the incoming pulse does not determine the energized duration. Here's an example of the 3 different one-shot functions afforded by this single multifunction timer. To set this particular multifunction timer to perform the rising edge pulse function for a period of 5 seconds, the technician would rotate the function selector to function E, rising edge pulse function, as illustrated in the previous table. Then a technician would choose the appropriate delay period. This particular manufacturer necessitates a 2-step process to adjust the delay period. First, one would select the range, and then adjust the range percentage. The range selection from the previous table presents possibilities from 1 second up to 100 hours. The percentage can then be used to fine-tune the delay period inside this range. For example, 50% of 10 seconds would be a delay of 5 seconds. Note this timer has 2 indicator LEDs, one that indicates when the device is powered up, and another that indicates when the outputs are in their activated opposite state. Unfortunately, this timer does not have an LED indicating when the auxiliary controlling input is also asserted. This would be a great feature, but sometimes you got to work with the tools you've got at hand. You know you set up the rising edge pulse function E correctly if you energize the coil and see the output immediately change states. Wait 5 seconds for the one-shot period to elapse and see the output return to the deactivated state. Again, if I turned off the coil during the ongoing 5-second one-shot, this particular function would be immediately reset. To set this particular multifunction timer to perform the falling edge pulse with auxiliary voltage for a period of 5 seconds, a technician would rotate the function selector to function F, the falling edge pulse function with auxiliary voltage. Then a technician would choose an appropriate delay of 5 seconds using the previous steps. You know you set up the falling edge pulse function F correctly if you power up the timer, energize the auxiliary controlling input for a period of longer than 35 milliseconds, de-energize the auxiliary controlling input, and then see the output immediately change states. Wait 5 seconds for the one-shot period to elapse, and see the output return to the deactivated state. Finally, to set this particular multifunction timer to perform the pulse forming function with auxiliary voltage for a period of 5 seconds, a technician would rotate the function selector to function G. Then a technician would choose an appropriate delay of 5 seconds using the previous steps. You know you set up the pulse forming with auxiliary voltage function G correctly if you power up the timer, energize the controlling input, and see the output immediately change states. Wait 5 seconds for the one-shot period to elapse, and see the output return to the deactivated state. Troubleshooters take note. A multifunction timer executing the right function at the wrong time needs to have the delay adjusted. In contrast, a multifunction timer executing the wrong function at the right time needs to have the function adjusted. I'd like to say a misinterpretation of functions is a rare occurrence, but it isn't, and you need to be aware of this possibility. Let's now move on to the remaining topics of this lecture. putting a timer executing the one-shot function to use. The one-shot function is characterized by the output temporarily assuming the activated state for the adjustable one-shot delay period after receiving a trigger event. After the one-shot delay period has elapsed, the outputs return to their deactivated state. Triggering events can either be on a positive or rising edge, or a negative or falling edge of the controlling input. For these examples, we'll make use of a multifunction timer that necessitates the coil be continuously powered and requires the use of an auxiliary controlling input. Because this could get out of hand rather quickly with various incantations of resets and retriggerability, let's restrict our analysis to timing diagrams we're familiar with, namely simple positive edge and negative edge triggered one-shots as illustrated in these timing diagrams. Function F, negative edge triggered, and function G, positive edge triggered. Let's examine function G first, the rising edge pulse function with auxiliary voltage, essentially a positive edge triggered one-shot. The classic introductory example of positive edge triggered one-shots is the time-delayed response of two pilot lights. You note that the positive edge triggered one-shot is sometimes illustrated using the shorthand symbol of the pulse with the positive edge highlighted. It's kind of like a little top hat. This is not always a common practice, but I find it extremely useful. Note the coil of the timer relay is continuously powered by the connection rung 1. Opening stop would serve to completely depower the timer. Rung 2 contains a momentary contact normally open start button on the auxiliary controlling input of timer relay TR1. Rung 3 contains a normally closed contact, TR1A, associated with timer relay TR1, executing the positive edge triggered one-shot function in series with the red pilot light. Rung 4 contains a normally open contact, TR1B, associated with timer relay TR1, executing the positive edge triggered one-shot function in series with a green pilot light. Again, this timer executing the one-shot function is positive edge triggered, is non-retriggerable, has no reset, necessitates external power, and is set to execute a 5-second delay. Note the start state of this circuit is red light on, green light off. When an operator presses and releases start, the auxiliary controlling input of timer relay TR1 experiences a rising or positive edge transition. Contacts TR1A and TR1B executing the positive edge triggered one-shot function immediately change states. TR1A opens and TR1B closes. The red light turns off and the green light turns on. Given the positive edge has already initiated the one-shot, an operator can release or continue to hold start closed. It really doesn't matter since the one-shot has already been triggered and is already headed downrange. Let's say an operator releases start halfway in. After the one-shot delay period of 1, 2, 3, 4, 5 seconds has elapsed, these contacts return to their deactivated states. The TR1A contact recloses and the TR1B contact reopens. The red light turns on and the green light turns off. We return to the start state of our system. Given that this is a non-retriggerable one-shot, if an operator pressed and released start and then pressed and released start again within the ongoing 5-second one-shot period, the system would ignore this second input and continue to execute the first action. If you think about this, the function of the one-shot is to execute a single action once for a specified time period when an operator presses start. However, if the function is ongoing, to ignore repeated inputs. Before we move on to the next example, consider the utility of the stop button in rung 1. If an operator pressed start, the one-shot function is triggered and contacts TR1A and TR1B executing the positive edge triggered one-shot function immediately change states. Even if the operator released the start button, the timer would already have started its 5-second countdown. If an operator changes their mind during the ongoing countdown and wishes to cancel it, opening stop completely depowers the timer and the associated contacts immediately return to their deactivated states. The stop button therefore serves to override and cancel an ongoing positive edge triggered one-shot. When stop recloses, the timer is reset to the start state. In summary, this system making use of a positive edge triggered one-shot executes a single action for a specified time period when an operator presses start. However, the function is ongoing to ignore repeated inputs. Additionally, the stop button serves to cancel an ongoing one-shot. Let's now examine the same system's response if the timer relay was performing function F, the falling edge pulse function with auxiliary voltage, essentially a negative edge triggered one-shot. And the timer executing the one-shot function is negative edge triggered. It's non-retriggerable, has no reset, and it is set to execute a 5-second delay. Note the start state of this circuit is red light on, green light off. Note that negative edge triggered one-shots are sometimes illustrated using the shorthand symbol of a pulse with a negative edge highlighted. This is not always a common practice, but I find it extremely useful. When an operator presses start, the auxiliary controlling input of timer relay TR1 is energized, and nothing happens. Tier 1A and Tier 1B remain in their deactivated states. The red light remains on, and the green light remains off. In fact, an operator can press and hold start all day long, and nothing will continue to happen since the timer has not yet experienced a negative or falling edge. Only when an operator releases start does the timer controlling input experience a negative or falling edge transition. Contacts Tier 1A and Tier 1B executing the negative edge triggered one-shot function change states. Tier 1A opens and Tier 1B closes. The red light turns off and the green light turns on. After the one-shot delay period of 1, 2, 3, 4, 5 seconds has elapsed, these contacts return to their deactivated states. The Tier 1A contact recloses and the Tier 1B contact reopens. The red light turns on and the green light turns off. We've returned to the start state of our system. Given this is a non-retriggerable one-shot, if an operator pressed and released start, and then pressed and released start again, i.e. gave the timer controlling input more than one negative edge within the ongoing 5-second one-shot period, the system would ignore these additional inputs and continue to execute the first action. If you think about this, the only difference from our previous circuit using a positive edge triggered one-shot and this one using a negative edge triggered one-shot is that the one-shot function is now only enabled when an operator releases the start button. As previously, the stop button serves to completely depower the timer. This could be used to cancel a previously triggered one-shot during an ongoing countdown and immediately return the associated contacts through the deactivated states. Besides making some stupid lights blink, a timer relay executing the one-shot function can also be used to coordinate some industrial task. Consider a two-part system that, when started, necessitates one of the actions occur continuously and the other action only once for a specified time period. Examples might be opening or closing a valve, heating something up, or sounding an alarm. The positive or negative edge triggered natures of the timer would dictate when the second action occurs, either at the start or at the end. Allow me to demonstrate. Consider a timer relay executing the positive edge triggered one-shot function put to use in such a circuit. By all means, pause the lecture and walk yourself through this circuit and see if you can figure out how this system works. Note the buzzer in rung 4. Let's assume this is a positive edge triggered, non-retriggerable one-shot that necessitates an external power connection. Let's say the timer is set to 3 seconds. If you're tracking, you should have observed the following behavior. When an operator presses start, the timer relay controlling input experiences a positive edge, and the F contactor coil is energized. Given the timer is executing the positive edge triggered one-shot, contact TR1A immediately closes and the buzzer starts sounding. When the F contactor coil is energized, its associated contacts change states. The F1 holding contact closes, allowing an operator to release the start button. The F primary contacts close, the brake is released, and the motor begins rotating. After a period of 3 seconds, the timer relay executing the positive edge triggered one-shot returns the associated contacts to their deactivated states. Contact TR1A opens and the buzzer turns off after 3 seconds. The motor continues to run after having given an audible alarm for 3 seconds at the start of a process. Opening the stop button would serve to de-energize the F contactor coil and the timer relay controlling input. When an operator releases the stop button, we've returned to the start state of the system. Note that the E-stop and the normally closed overload would serve to completely depower the timer, as well as the F contactor coil. Let's take a look at another circuit entirely, this time making use of a negative edge triggered one-shot that is also non-retriggerable and set to, let's say, 10 seconds. Note this system is a mix of motor control and electrically controlled hydraulic systems. Don't bust an O-ring trying to lift this thing. Note not all of the ladder logic is shown for purposes of simplification. The part we are interested in features the P contactor coil, which energizes a motor-driven pump, and DCV2 Sol A, which shifts the normally closed directional control valve 2 into an open position. By all means, pause the lecture and see if you can walk yourself through this system and see how it works. Quick hint: note the accumulator in this circuit and its relation to DCV2. If you have no idea what an accumulator is, by all means check out the accumulator lecture available at the Big Bad Tech channel. If you want to save some time, here's a summary. An accumulator is a hydraulic energy storage device that, while versatile, can be considered a source of hazardous energy if it is not properly discharged. Again, we're using a negative edge triggered one-shot, as indicated by the top hat on top of the TR1 relay. If you're tracking, you should have observed the following behavior. When an operator presses start, the P contactor coil is energized, as well as the coil of control relay CR1. The P primary contacts close, and the motor-driven pump starts providing flow to the hydraulic system. The contacts associated with control relay CR1 also change states. CR1A closes, which establishes a holding circuit, allowing an operator to release the start push button. When CR1B closes, the auxiliary controlling input of timer relay TR1 is asserted. This timer is, however, executing the negative edge-triggered one-shot function, and contact TR1A remains in the deactivated open state. At a certain point, pressure in the accumulator rises to the set value of pressure switch 1. PS1 opens and de-energizes the P contactor coil. The P primary contacts open, and the motor-driven pump stops. Given the holding contact established by CR1A is still asserted, the larger hydraulic system can use the pressure inside the accumulator for its own purposes. If pressure ever dropped below the reset value of PS1, PS1 would reclose and the motor-driven pump would repressurize the system. The system could do this all day long, cycling between the reset and set values of PS1. However, when an operator presses stop, the coil of control relay CR1 is de-energized, and its associated contacts immediately return to their deactivated states. CR1A opens, removing the holding circuit. CR1B opens, and timer relay TR1 has experienced a negative edge. Contact TR1A executing the negative edge triggered one-shot closes and energizes DCV2 solenoid A. The energized DCV2 Sol A shifts DCV2 to the open position and discharges the accumulator to tank. When pressure falls below the reset value of PS1, PS1 closes. After a period of 10 seconds, the timer executing the negative edge triggered one-shot function returns the contacts to their deactivated states. Contact TR1A opens, de-energizing DCV2 Sol A. The spring offset valve returns to the closed position, and we return to the de-energized start state of this system. Note how this timer executing the negative edge triggered one-shot function ensures that this system's last act of the day when it's turned off is to discharge the accumulator, thereby contributing to the safety of the larger system. Before we bring this introductory lecture to a close, let's compare and contrast the last two examples. The positive edge triggered one-shot briefly sounded an alarm when a motor was first started. In contrast, this negative edge triggered one-shot briefly dumped an accumulator when the pump was shut down. Allow me to memorably summarize the differences between positive and negative edge triggered one-shots. This may or may not help you mentally categorize the two. Hopefully it doesn't confuse you more. I like to think of positive edge triggered one-shots as those functions that must occur once when something starts. Examples being when an operator first presses a button or at the moment some automatic input is initially triggered. In contrast, I like to think of negative edge triggered one-shots as those functions that must occur once when something ends. Examples being when an operator releases a button or when a system shuts down. Let me issue this quick challenge testing your understanding of the above concept. Consider the act of starting a motor, then rapidly decelerating it by briefly plugging it in the opposite direction when you stop it. of the timing functions we've already discussed, which function is most appropriate for this action? If you think you know the answer, by all means, write your answer on a $50 bill and send it to me. Expect us to revisit this application and make use of both positive and negative edge-triggered one-shots in later lectures. Alright, that is that. In conclusion, this lecture took a brief look at multifunction timers performing both the positive and negative edge-triggered one-shot function. We introduced positive and negative edge-triggered one-shot functions, reviewed general timer functions, learned how to set up an example timer relay to perform positive and negative edge-triggered one-shot functions, and finally employed a timer executing both the positive and negative edge-triggered one-shot function and several illustrated examples. Remember to review these concepts as often as you need to really drive it home. Imagine how well lab will go if you know what you're doing. Thank you very much for your attention and interest. We'll see you again during the next lecture of our series. Remember to tell your Lazy Lab partner about this resource, and be sure to check out the Big Bad Tech channel for additional resources and updates.